let's talk about important data type, that is Bigint. So Bigint is introduced later after the initial number data type to solve the problems of the capacity of the number data type. There's a small difference between the big int and the number. Apart from the big int can store a bigger number as compared to the number data type. The big int only supports the integer value. It can't support the fractional values or maybe the floating point values. As the name itself suggests, it's a big integer. Let's try to see with some example here. So if I just want to write any big int data type, I just need to say, for example, 1. So this is a normal number in this case. And if I want to convert this as a big int, I need to append this with small n here. So now this literal is becoming a big int and we are storing inside a variable called n. Apart from this, we can also do this in with one more variation. Let's say this is n1, this is n2. We can also use a global method called big int for a bigint creation here. And if I just check the type of this both now, the type of N1 and the type of N2. So both are representing the big int here now. Now let's try to understand where the capacity of our number ending and from where we should start using the big int, because of course the big int will occupy the larger memory and it will have some bigger complications due to its size and everything for internal operation. So we should not always use the big int. We should only use it whenever we require for any high level operations where the large capacity is needed. So let's understand what's the capacity of existing number data type. So for that, okay. So to understand that capacity, let me just call and use a property called max safe integer. So inside the number object, there is a property called max safe integer, and it says that the maximum number can be stored as a number data type in JavaScript is this one, that is 2 raised to power 53 minus 1. If beyond this, if I try to use, it will store it. It will not going to throw any error, but the accuracy or the precision will not be that much correct. Let's try this with a small example. So here I'm saying n plus 1. So what is the maximum number is present? In that I'm trying to add one more extra number. So let me just first represent this is the maximum possible number, and in that I'm trying to add 1. So till this point everything is good. Okay, no problem. Let's try doing with the adding the next numbers in that. 7. Let's see. Okay, so now we should observe one strange behavior here. So we are able to see this is original 91. This is the maximum number. Inside that I'm adding 1. So here, okay, I'm getting good. But here I'm adding 2. So we should get the 93 here, the 94, 95. So here the values are not correct. And this is due to the maximum safe integer number supported by the JavaScript as a number data type is this one. If beyond this, if you try to store any value, it will keep losing its precision and the accuracy. So that's the reason this is the maximum safe number in JavaScript. So if I want to have any calculation beyond this, of course, there can be certain requirement. So how we should proceed for that? So for that, we need to use the big int. So very first thing what I'll do, I'll convert this number to a big int. So here I can use this big int method and pass my number to that. So now it will return me a big number. And if I want to confirm that, what I can do, I can just say the type of n now. Now I should get the big int. And here if I check the type of n, here I should get the number. Yes, previously it's a number. Now then I convert it to a big int. So this is pretty clear now. And now I'm just trying to display my big int number on line number 13 and line number 14. I'm just trying to add one extra number to the big int. Remember, in this particular expression, there are two values. On the left hand side here, n is representing your big int, and the right hand side here, the 1 is representing the normal number. Both are having the different data type. That is important to understand in this case here. Yeah, and that's the reason here we are getting one problem at line number 14. It is saying that cannot mix big int and other types use explicit conversion. It means that if there is any big int number in your expression, all the numbers should be the big int to complete that expression. So here the 1 is a normal number we need to convert into a big int. So how I can convert? I can just mention n here. So now this will become the big int, and this is also a big int now. Now the operation will be succeed. Now we can see the line number 14, we are getting the output 92, and at the end it is coming with n here, which is representing it's a big int. Fine. Now again we started getting error on the next line 15 here because of the same problem. Let me just correct it. Yes, now these are super correct. 91, 92, 93, 4, 5, 6, 7, 8. So now we are not losing any precision. We are not losing the accuracy of the number because Bigint is very big to handle these kind of numbers. Now let's talk about one more important situation here to understand the precision problem. So we understand what's the maximum number is there. This is the maximum number, right? So what I'll do here, I'll say if, or I'll just mention a console. Okay. I'm trying to compare these two big numbers. Both are the maximum safe integer. So almost we should get the true here itself, right? Yes, we are getting the true from the line number 22. That's super correct. Let me make it. This is 92 and this is 91. Now we should get false. Yes, of course we are getting false, but this is not guaranteed we will get the false because we are exceeding the limit given by the number. If you want to have this, you must represent this as a big number. Now you're inside a normal number, so there can be accuracy issues if you cross the maximum limit. And if you want to see some example for that, let's see. So ideally, this should be completely false because both are the different numbers, and make sure we are crossing the limits here given by the number data type. But surprisingly, if you see the outcome here, you will get true because both of these numbers are losing its precision and the comparison will not be that much correct and successful, we can say. So these are the issues. And if I just convert this as a big int number here, now it will be super correct and compulsorily it will be a false. Yes. Let's understand with one more. Let's say 1 equals to 1. So this is perfectly true that we know, line number 23. But if I compare a normal number with the same value which is represented in the big int, what will be the outcome? So here, this will be false. Why? Because both are having the same values but with different data type, and this is what the meaning of the three operators equal to operators. And if I just want to compare its values, so now we should get true out of this, line number 24. So we are getting true out of it now. Next, as we have already confirmed, the big int is only allowed to store the numbers, not the floating point. It is only allowed to store the integers. So let's prove with some example here. So I'm creating some number here, which is a big int. And here I want to store 1.5, for example, so it's not allowed. If you just hover your cursor, it will give you very clear error. The big int literal must be an integer. The floating point is not spotted. So this is straightforward that we are assigning, but let's say the expression is generating the floating point number. So what will happen in that case? So that's an interesting point to see. So let's make it 3 divided by 2, and I'll say both are the big int numbers. So of course we should get the 1.5 here now. The results out of this particular expression will be 1.5, but it's interesting to see what is the value inside this N3 now. Let's see if we are getting one big int value only. So what is this precision is coming? It is completely avoiding that. And that's what the meaning of the big int. It is capable to store only the integer values. As we already know, like we can also store the binary number, hexadecimal, octal number also in the normal number. We can also do the same thing with big int as well. Let's see how. So let's say, for example, this is a binary number. How we generally store it? We say 0, then we mention a binary and we'll say 100. Okay. So this is how we represent a binary number. And if you want to represent the same binary number with a big int here, so you just need to mention again n here. The same way is applicable with hex as well. So generally we mention the hexadecimal number with like this. And if you want to store this hexadecimal number by using a big int data type, again, you just need to mention n here. So this is how a big int works. It solves the problem of the capacity coming in the number. And there are also some limitations like if it is inside any expression, compulsorily all the elements inside your expression should be big int. It is not capable to store the floating point values, the important calculations with comparisons with normal number and the big int we have seen in this lecture.